Sample problem 10.10. Another air purification method for enclosed spaces involves the use of scrubbers containing aqueous lithium hydroxide, which reacts with carbon dioxide to produce lithium carbonate and water. 2 LiOH aqueous plus CO2 gas produces Li2CO3 solid and H2O liquid. Consider the air supply in a submarine with a total volume of 2.5 times 10 to the 5 liters. The pressure is 0.9970 atmosphere and the temperature is 25 degrees Celsius. The pressure in the submarine drops to 0.9891 atmosphere as a result of the carbon dioxide being consumed by an aqueous lithium hydroxide scrubber. How many moles of CO2 are consumed? Okay. All right, so let's take a look at this one. They could have made it more difficult than they did. Essentially, we are going to find out how many moles of CO2 are scrubbed. Or scrub it out of the air, okay? We're removing it. So what happens is you've got this solution, carbon dioxide bubbles through it, it dissolves and reacts, and that takes the carbon dioxide out of the air. And then the air goes through this solution and back into the air supply. Lithium carbonate is produced, as is water. Okay? So the main thing here is that we want to find the moles of CO2. So we're going to use PV equals nRT. We know that N would be PV over RT. But we have two pressures. It starts off as 0.9970 atmospheres, and it ends as 0.9891 atmospheres. So here's what we're going to do. We're going to say the number of moles of carbon dioxide that is absorbed, that is scrubbed, that's the change in the number of moles, would be equal to the change in the pressure, I'll put that in parentheses, times V over RT. Okay, so the change in the moles is equal to the change in the pressure times V over RT. The volume's not changing, the temperature's not changing, R is certainly not changing. The pressure is changing, and so the number of moles is changing. Okay, so in a way, you could say it's this. N2 minus N1 is the change in the number of moles, and that's equal to P2V over RT minus P1V over RT, which is equal to delta P times V over RT. Okay? So that's how this works. So we just need to know the change in pressure. So that would be the final pressure. So 9891 minus 9970. I'm going to put atmospheres outside, times the volume, which is very large. It's a submarine, right? And then we're going to divide that by RT. Temperature is what, 25? 298.15 Kelvin. Okay, so let's see what that difference, I'm just going to take the larger number and subtract the smaller one. Okay, not a big difference, but it's enough there. Actually, if you breathe a lot of carbon dioxide, you can get very sick. So that's 0.0079. I'm going to go ahead and go through the dimensional analysis now. Atmospheres are gone, liters are gone, Kelvin is gone. So we have 1 over moles, which is moles. Okay, so 0.0079 times 2.5 times 10 to the 5. You might say, hey, wait a minute, shouldn't it be negative? And that's fine. If you want to make it negative, you can. It decreased, the amount we have decreased. And then this is going to be in moles. We already figured it out in the previous step that that's moles, okay? So 0.0079, 2.5 times 10 to the 5, and then divided by RT. So 0.0079 times 2.5 times 10 to the 5 divided by 0.08206 divided by 298.15, and it looks like it's about 80.7 moles. So the change in the number of moles in the submarine is negative 80.7. It went down by 80.7 moles because it was absorbed by this scrubbing device, which is the reaction of lithium hydroxide with carbon dioxide.